Let's take a look at transformations of parent functions. When we're looking at these, what I want you to keep in mind is that the notation that I use, f of x, is going to represent any parent function. So f of x represents any parent function. Translations, we can shift our functions up and down, or we can shift our functions left and right. To shift up and down, we will have our parent function, and then we will add some value c. If we add some value c, that is going to shift up c units. So when you go to graph your parent function, you'll just start from a different place. If we have f of x minus c, that is going to shift down c units. To shift left and right, that number that we're adding or subtracting is going to be inside the parent. If we have f of x plus c, that is going to shift left c units. And if we have f of x minus c, that is going to shift right c units. Here's some examples. Let's use the parent function y equals x squared, or f of x equals x squared. If we're shifting up 13 units, what we're going to do is take our function y equals, and then we're going to take f of x represents x squared, so shifting up, we would take f of x, which is x squared, plus 13 units. But if we were going to shift left 13 units, then y would equal, notice that the x plus c is inside the parent. Well, the parent in this case is something squared, so I would take the x plus 13 inside the squared. And this will work for any parent function. So if it's outside of the parent, it will be up and down. If it's inside the parent, it will be left and right. Vertical stretches and compressions. That is when we take a value, c, times our function, f of x. And that will be a stretch if c is greater than 1. It will be a compression if c is bigger than 0 but smaller than 1. So here's an example. We could have y equals 4 times x squared. And that would be a stretch. And the way that we would graph that is we would take our pattern of over 1, up 1, over 2, up 4, over 3, up 9, and we're going to multiply all of our ups by that 4. When we have a compression, say we had y equals 1/4 x squared, we're going to do the exact same thing. This is a compression, and to graph it, we'll just go use our pattern, over 1 up 1, over 2 up 4, over 3 up 9, and we're going to multiply all of our ups by 1/4. And that's going to make everything shorter. That's why it's a compression. So to graph with these, what we're going to do is keep the same x values. So we're going to keep the same left and right. And then we're going to multiply the y values, or the ups and downs, by the number out in front. Reflections. We can have two kinds of reflections. If we have a reflection that gives us a negative sign outside the parent, that's going to reflect over the x-axis. In other words, it's going to flip your function upside down. That's how we had our parabolas that opened down. But if we have a reflection across the y-axis, it's going to put the negative inside the parent. So if we had y equals negative x squared, what that's going to do is it's going to change the sign of our y values. So instead of going over 1, up 1, we'll go over 1, down 1, over 2, down 4, and over 3, down 9. When you reflect over the y-axis, what you're going to do is you're going to put the negative inside the parent with the x. So it will be negative x squared. Well, that's not going to make a big impact on our parabola because that parabola already has that y-axis symmetry. So I'm going to switch my x values, but when I switch 2, 4 with negative 2, 4, they just end up right on top of each other. So that one doesn't show a big difference, but in general what you would do is change the sign of the x values. So you will see some of these making a difference in our other graphs.